All right, folks, we're going to rejoin you right now. It's good to see you again, and we're going to take care of the remaining part of 2.3, which is entitled The Algebra of Functions. In 2.3 Part A, in that last video that we had done, we had identified the domain of a function being illustrated by an equation. And now in this second part, which we're calling B, we're going to be taking two different functions and we're going to combine them. And when we combine them, we're going to do one of four operations. We're going to add the functions together, we're going to subtract them, we're going to multiply them, and we're going to divide them. Now, when we do get down to the division one, we are not literally going to do any division, but it is a division problem that we're going to be taking a look at. Now, the key to the algebra of functions when we are combining functions together, we have to have a plan. We have to have a rule in order to add functions, subtract them, multiply, and divide them. And on this sheet of paper right here that Kristen is going to show here, these are the four basic rules that we're going to need to make sure that we follow when we're operating or combining with functions. Here is the addition one. Now, I'm going to read this in actually the way that it should be read. I'm going to read it without saying the word of, because we really shouldn't say the word of. So this is the name of the function. This is the domain. And the entire expression that I'm circling with my finger is the range, or your y. So here's the proper way to read it. The value when function f gets added to function g, when the domain is x, is equal to the value of f when the domain is x plus the value of g when the domain is x. This left-hand side is equal to the right-hand side, and it almost kind of gives the idea that we are distributing. We're not, but it almost kind of gives the idea that we're going from him to the domain plus the function g to the domain of x. It almost kind of gives that idea. And the subtraction rule is the same thing. The only difference is we're subtracting. The value of function f decreased by function g when the domain is x is equal to the value of f when the domain is x minus the value of g when the domain is x. We are going to have to memorize these rules. It's not going to take much. You'll get it memorized by just getting your practice in. The multiplication rule. The value of function f multiplied by function g when the domain is x is equal to the value of f when the domain is x multiplied by the value of g when the domain is x. And then the division one. The value of function f divided by function g when the domain is x is equal to the value of f when the domain is x divided by the value of g when the domain is x. And I put this final plug in here. I don't think it would have really made any difference to you one way or another, but we should acknowledge the fact that the value of g when the domain is x, it cannot be equal to 0 because it would be undefined if it were. So I'll kind of keep that sheet of paper up there as we move through the examples of combining functions in this video. We're going to begin with addition. We'll move to subtraction. We'll go into multiplication, and then we'll do a division. And I think the only thing that I'm going to do, I'm going to move this guy. So I've got this entire board. Just going to move it, and I'll just kind of put it on this side wall right here. And when I refer to it, if Kristen can kind of show it right on there, that would be good. But here's the information. Here's what we're going to be doing. You got to have something to work with. You can't go operating with functions until they identify the two. So we're going to be talking about function f, and we're going to be talking about function g, and here's what they are. Let the value of f when the domain is x equal this range value, this trinomial, 3x squared plus 4x minus 1. This is function f, and you can see written as an equation. And then we have function g. The value of g when the domain is x is equal to this binomial, 2x plus 7. So we have to have functions, two different ones, in order to operate with them. And I kind of wrote the direction over there on that right-hand side where it says, find each of the following. There's going to be a total of 7 overall problems that we're going to look at. Here's number 1. They're asking us to find the value of function f plus function g when the domain is x. So I wrote down number 1, and I wrote down what they're wanting us to find. Well, you'll notice they've given us the left-hand side of the addition rule. They've given us this. They want us to find this. Well, the first thing that we're going to do is write an equal sign, and we're going to write out the remaining side of this rule. We're going to write this down. So, the value of f plus g when the domain is x is equal to f of x plus g of x. Now, folks, we're going to bring down an equal sign, and we're going to evaluate. We're going to find the following. We're going to get an answer. We're going to follow this recipe right here to get our answer. F of x is this trinomial. So in place of f of x, we're going to put this trinomial, and I'll tuck it. 3x squared plus 4x minus 1. Bring down your plus. And now we're going to add to that function the g of x function. And the g of x function is 2x plus 7. Now, folks, for the sake of room right here, I'm not going to pull this trinomial out of its parentheses, and I'm not going to pull that binomial out. It's asking us to add this tri with this bi. And when we add them, we combine like terms. So I'm not going to rewrite it at all. We're just going to come down and write our final evaluation. When that's written down, now we're going to bring down the value of f plus g when the domain is x is going to be equal to the outcome that we're going to get when we combine those like terms. Now there's only one quadratic term here, so we'll bring down that 3x squared. We'll combine this linear term of a positive 4x with a positive 2x there, and that'll give us a positive 6x. And then we'll combine this negative 1 with that positive 7, and we'll have a positive 6. And here is the outcome. There is our range value after those two functions got added. So there's number 1. That's the look of number 1. Now we go to number 2. And they're asking us to find the value of function f plus function g when the domain is 4. Well, that's going to be a very easy task to do because we just got finished right here finding the value of f plus g when the domain was x, and that turned out to give us this answer, this range value. Now they're asking us to find the value of f plus g when the domain is 4. So folks, I'm going to move into number 2 right here, and we're going to begin by writing this statement. The value of f plus g when the domain is 4, and we'll put an equal. And now the fastest way to get this is to take our domain value of positive 4, and we're going to substitute it in place of the x here and the x there. And we're going to evaluate that, and we will then have the range value for this one. We just found the value of f plus g when the domain was x, and that was this. Now the domain value of x is a numerical value of 4. And we're just going to come and we're going to substitute. Bring down that coefficient of 3. Make a house. Inside that house, put the value of x, or the value of the domain, 4, and stick that exponent out there. Bring down that positive 6. Make a house. And in place of that domain letter of x, put 4, and then positive 6. Come down with an equal. 3 times 4 squared. Don't make the mistake of multiplying 3 times 4. That's completely out of the order. 4 squared is 16. Now I could outright multiply that part right there, but I didn't. I just brought it down. Now another line. That should give 48 plus 24 plus 6. And now I know I'm all the way down here at the bottom, but now we'll write our culminating statement. The value of f plus g when the domain is 4 is going to be equal to whatever the sum of those 3 numbers are. 6 plus 24 is 30. And 30 added to 48, I think, would give us 78. And that little puppy gets circled, and that's the range value for problem number 2. That's the look. Now I'm going to erase, and we're going to do 3 and 4 and put them together. Find the value of f minus g when the domain is x. Well, the value of f minus g when the domain is x. The value of f minus g when the domain is x is equal to f of x minus g of x. So right over here, that's what we're going to put. F of g minus f of x, minus g of x, bring down the equal, f of x, go up to your given, f of x, this trinomial, bring it down. You don't necessarily need to tuck it. I'll go ahead and tuck it. 3x squared plus 4x minus 1. Then minus. Now here's where it's important. Minus g of x. Minus g of x is not just one term up there. It's a binomial. You have to tuck and put that binomial in there. You have to tuck. And then, folks, before we go to the action of subtracting, I believe it would be important. I'm going to share this. I've shared it before. But being that there's a minus sign right there, that's going to indicate that when we subtract, the two terms at the very end right here are going to have to go through a sign change because that's the rule of subtraction. We're going to insert a distributor of -1, and that is going to do the trick for us when we do the subtraction. So bring down the equal, bring down that trinomial as it is. 3x squared plus 4x minus 1, and now we'll distribute. -2x and -7. Now, let's write down our concluding statement because we're ready for the range value. The value of f minus g when the domain is x is equal to 3x squared positive 4x coupled with a -2x, positive 2x. You got a -1 and a -7 for a -8. There is the range value for problem number 3. Don't forget the parenthesis. Now number 4. It wants us to find the value of f minus g when its domain is -2. So I'll just put a number 4 right here. We'll try to squeeze it in. If I have to put the rest over there, I will. The value of f minus g when the domain is -2 is going to be equal to, wherever we see the domain letter, he's going to get a -2. So bring that 3 down and bring the house down and put the exponent outside there. Stick the -2 there. Bring down the +2 times the -2 and then the -8. Bring down the 3. Make the house. -2 to the second power would give us 4. +2 times -2, -8. Another step, multiply out. 12. Positive times negative would give us a -4 coupled with a -8. And I'll put that culminating statement kind of right over here because we're ready for it now. The value of f minus g when the domain is -2 is equal to 12 minus 4 is 8, and 8 minus 8 is 0, and there's the answer to number 4. Pretty doggone basic to do. We just need to get familiarized with the rules and follow them. And by getting the practice in, like I already said, you'll have it memorized. You'll know exactly what you have to do. Okay, now a little bit different action on number 5 because this just wants us to do this. It's not giving us the value of f times g when the domain is x. Could have, but it didn't. It wants us to find the value of function f times function g when the domain is 3. Now we're going to write an equal sign, and we're still going to write an expression on the right-hand side that will complete this equation. And we're going to do much the same as we would ordinarily do if the domain were x. I'll come back over here. If we were multiplying f times g when the domain is x, that would be equal to f of x times g of x. Well, our domain is not x, our domain is 3. So we're just going to, in place of the x on that right-hand side, we'll just go ahead and put a 3. So the value of f times g when the domain is 3 is equal to f of 3 multiplied by g of 3. And now we're going to do this. It's a little bit different, but we're going to do this. We're going to find the value of f when the domain is 3, and we're going to find the value of g when the domain is 3, and when we get this value and we have that value, we're going to multiply them together and we'll have this given answer. So, come down over here on this left-hand side, and I'm going to copy down function f. F of x is equal to 3x squared plus 4x minus 1. And I'm going to get the other one ready as well. And g of x is equal to 2x plus 7. Now, going this way is the way that I'm going to do it. You could do this if you wanted to. I'm going to mention it. I'm not going to, but you could. Even though this problem is asking you to find the value of f times g when the domain is 3, you could, at the outset, you could find the value of f times g when the domain is x and get that answer. And then find the value of f times g when the domain is 3, just like we did problems 1 and 2 and 3 and 4. But I'm not going to do that on this one. We're going to handle it just in the way of what it says here. So here's function f. Now we're going to find the value of f when the domain is 3. And so we're going to insert in 3 times the quantity of 3 squared plus 4 times 3 minus 1. 3 times 9 plus 4 times 3 minus 1. 27 plus 12 minus 1. F of negative 3 is equal to, I believe, 38. I'm just going to kind of circle that. Now that's the value of function f when the domain is 3. Let's do function g when the domain is 3. G of 3 is equal to 2 times 3 plus 7 is equal to 6 plus 7. G of 3 is equal to 13. Not that you're going to have to write down what I'm about to do, but I'm going to kind of erase this little part right here so I have a little room. I'm not going to erase the answers. Just a little bit of room right here that I'd like to write for the summation statement. The value of f when the domain is 3 times the value of g when the domain is 3 is equal to the value of f when the domain is 3 was 38 is equal to 38 times the value of g of 3, which was 13. And now Now we just come down and we multiply those. 38 times 13, that'd be 24. I believe 11, 38, 4, 9, 4 would be equal to 494, and that would be that given answer. So there's a little bit of work. A little bit. Let's do the last two. Now, the last two are working off of division. Number 6, kind of a quick one. The value of function f divided by function g when the domain is x is equal to, well, it's telling us right here what it's equal to. See, they just gave us this. It's equal to f of x divided by g of x. So, make the bar. And in place of f of x, it's this trinomial, 3x squared plus 4x minus 1 over g of x, which is 2x plus 7. And folks, we're going to leave the answer just in that way because number one, there's a couple of things. You wouldn't be able to reduce this because 3x squared plus 4x minus 1, I don't believe it can be factored. And 2x plus 7 can't. And the only other thing that we could do is maybe do a long division. But the long division would be a messy, messy situation. Because if you try to divide the first term of 2x into the first term of this, it's not going to go evenly. And we'd be getting a headache. So our answer is just left like this. The value of f over g when the domain is x is equal to him, and he's done. We're not doing anything more. That is the range value. Now number 6 leads to number 7, and we just kind of came from this. Number 7 says, find the domain of f over g. There's f, and there's g, and there's a fraction there. And more importantly, the denominator contains an expression that contains a domain variable. So in order to find the domain of f over g, we're going to have to first of all find out what cannot be a part of the domain. Oh, it'll be a lot of numbers, but it's not going to be able to be one number. And we're going to have to find that value of x that will cause that denominator's value to be 0. So we take that denominator of 2x plus 7 and we set it equal to 0. And we solve this for x. Negative 7 on both. We'll get 2x is equal to a negative 7 over 2. And over 2, and here's what the domain cannot be. It can't be negative 7 over 2. It cannot be a negative 3.5 or a negative 3.5. It cannot be negative 7 over 2. But it can be any value that is less than negative 7 over 2, or any value that is greater than negative 7 over 2. Once again, if you just wanted to see this, let's call that 0. Negative 7 over 2 would be about a negative 3.5. We'll just put him right here. You see, it can't be him, but it can be any number less than that, or it can be any number greater than that. So the domain would be equal to parentheses or parentheses. For this one, let's do the one where the domain can be a real number that is less than negative 7 over 2. Well, then the negative 7 over 2 is going to be the largest number in that interval, and this will be a negative infinity. And in the other one, the negative 7 over 2 will be the smallest value, and we can take it out to positive infinity, and there would be the domain of that. So you have now seen the algebra of functions. That is what 2.3 is about. Okay? You take care of yourself, and we'll be moving forward in this and getting the things done that we need to do. Take care. Have a good day.